Hello again, Blue Chip Consulting here. I'm going to walk you through cutting a few simple parts on the plasma. I got the plasma set up pretty much where I left off with the part 2 of the router to plasma conversion, table conversion. So we got water in the table. I'm going to be cutting a 6 by 3 inch plate out of 12 gauge hot rolled sheet metal and piercing 2 pilot holes in the plate. This is for a jig that I'm making for some woodworking. So I've cut 8 of them already, so the machine is set up to a certain extent, but I'm going to walk you through like it's not. This is the scrap that I'm going to cut it out of. I'm going to get 6 of them out of here, right across here. I'm going to get 4 of them out of here, right across the bottom there. The last one being a little bit smaller than the first 3 to fit that previous cut. So to get started here, what I do is set my metal down roughly in the area that I'm going to work in. Since I'm using my tabletop tool change shelf, which extends into the work area, I use this spacer to keep me off of the shelf by 1 inch. This is a 1 inch by 1 inch square tubing. So it's just a nice parallel square bar that I can put in there and get this roughly registered, because the gantry is square to my blue frame, the open frame bed. The shelf sits on top of the water table slats and has a lip on it in the front, has a flange on the front that is pretty straight. This is a shelf out of some equipment box that I salvage, and aluminum. And I just pull it right up against the frame, and then I use the parallel edge on the far side as my edge to set this up. And it's within a millimeter of being, where I need to be with it. So, given that, I'm going to set my 12 gauge down on there. I've already homed my machine. I do need to service my torch, so I'm going to be doing that. But first, let me set up and clamp this piece of scrap material. And to do that, I've homed the machine, so I'm going to click a macro in UGS. I have 14 or so macros that facilitate routing, laser, and plasma cutting. And I bring it up to what I call my tool change position, which is a convenient place for me to work with the shelf underneath. I'm going to service the torch. I'll tell you what, let's just do that now. We'll service the torch now, so I can take it off, magnetically attached. We went through that during the conversion. On the Z plate here, I have my locating parallel bars in vertical, and then I have a horizontal 3/8 bar welded on the plate. And these are square to each other and square to the table. I'll unscrew the container cup for the torch tip, and the swirl ring comes out. I just give it a quick inspection, make sure it looks dry, and keep the wrench handy here. And everything's good there. It's looks pretty good. Don't need to do any service to that. I am going to take this to a wire wheel and just knock off a little bit of that surface dross that accumulated at the tip there over the last couple of cuts. I always look down inside for any debris or any indication that I might have wet air. And so far so good on that. And then on the machine cup, of course the tip unscrews, and you're going to get a little bit of accumulation of some minor dross around that you want to keep you know, burnished off with a wire wheel and wire brush. Make sure this stays tight on there. So I'm going to take these over to my wire wheel and just do that real quick. All right. So now things look good here. And then last I checked the shoulder of this nozzle at the top, just inside the step down shoulder. And that's where the pilot arc starts. That's where it, the electrode moves back, spring loaded. See that? And when air is applied inside the nozzle, the pressure pushes this back in. And that's when the arc occurs. You create a gap between the electrode and the nozzle, and you get a pilot arc at the top, and then, you know, if you're at the correct pierce height, it's going to transfer immediately to the work lead attached to your work material. So I'm going to put the ring on in the correct direction so we get that clockwise swirl from the bottom. Put the container cup on. Make sure everything seats correctly. I know approximately where it's at. I also know that it's about a 30 thousandths offset from the bottom of the cup as far as the nozzle goes. I check for that. Put this back on. Make sure I got good side to side. Make sure I got good free movement here. Make sure it indicates that I have a probe switch. And then I press my resume button, because when I took it off, I tripped the interlock circuit. This switch is a reed switch like you'd use on a window for a security system in a house or a business. And these magnets here make the switch when it's in proximity to the magnets. So the switch is normally closed. The switch is normally closed, so it's closed right now. So the circuit is enabled. The machine's not going to move. So the Arduino software, well, the GRBL software is set so that once you make that circuit, the circuit, you're essentially in a pause state until you hit resume. Okay, so now I'm going to hit my resume. So I have this push button here, this red one is in parallel with that switch. So when I push it, I go into this safety door state. When I press resume, I clear that door state. When I press it again, you see the door state come up on a computer probably. That orange bar, and then resume clears it. So that's GRBL on the Arduino board that's doing that. Okay, so the torch is now ready, almost. I want to blast some air through it. A couple times. My air is set at 70. I've been running at 70. I'm cutting 12 gauge with a 60 amp tip, and it'll be 52 amps when it's cutting. I blew some air, so now I'm going to just test fire it, and I have a toggle switch here that I name plasma arming switch. Right now it's off. Anytime I service the torch, I turn it off. So this toggle switch is in series with the relay that is picked by the spindle enable signal coming out of GRBL. So The green light on here that you see means I have power to the board. That's just 5 volt. When the red light comes on that board, you may or may not see it, that means that M3 or M4 command is active. So that picks the spindle enable signal, which picks the relay, which would normally trigger the machine torch. However, the relay is in series with this toggle switch. So if the toggle switch is off like it is now, I can pick that relay all day long and I'm not going to fire the torch. So I call it my plasma arming switch. So the switch has to be up in order for the system to be armed. Now if I issue an M4, it's going to fire the torch. So I kind of use this in reverse when I test fire the torch. I put the switch off. I have a macro that issues an M4 for 10 seconds, and then it shuts it off with an M5. And what I do is I'll click that macro, and I have 10 seconds now. You might have seen the red light come on to fire the torch. And that's all I need to do. I just test firing it. Make sure the flame looks good, everything's straight down. Yeah, if your tip isn't right, you'll notice. The plasma jet won't look right. So I just toggle the switch, get a test fire, and I know that everything's working. I'll let that air, I'm on about a 15 to 20 second air delay for cooling. So there we go. Okay, so now I'm done with the torch, and it's mounted, and we're good there. So I'm going to pull up to the computer and take it to its, I know if I go to my last home position, I'm pretty much in the neighborhood because like I said, I've cut a couple of these. I had some identical scrap from a previous project that I've been cutting these plates out of. So this is the last of 3 that I'm cutting. So I used my spacer to get me in my Y position. And rather than move the plate, I'm just going to reposition 0 by shifting over. Once I bring the torch down, I bring it down at 5 millimeter increments. And now I'm just going to bring it over in 1 millimeter increments. And I'm looking to get the edge of that plate on the center of the torch. Again, this is plus or minus a millimeter, which is, okay, so now I take a mirror, and I put a mirror on here so that I don't have to get up and look down the other edge. And I'm looking to see if I'm at the center line of my torch, and if I'm not, I'm going to move it. So I'm going to bring the torch down 1 more 5. And I can see that I'm right on it, which makes sense because this is my typical starting point with that 1-inch spacer. So I'm going to bring it up 5, clear it off the metal, because it was basically touching there. What I'm going to do now is I have another macro that does a touch off so I can zero my torch to the top of the metal. So it's doing the same touch off command that I would do when I'm plasma cutting. It does 2 touch offs, 1 fast, 1 slow. The fast one's at 1,000 millimeters per minute, the slow one's at 50. And the reason you come in slow, it's just like the same thing, you see it when it homes, it does the same thing. And I think it's 1,050 are the parameters there also. And the reason for that is you don't want to overrun the closing of the micro switch. The speed does. All right, so I'm going to do it again. I usually do 2 of them just to, and if there's ever any question, I just pick this up and drop it. And I can see I'm just tapping that metal. And if I would take this up by a couple of tenths of a millimeter, it wouldn't be touching. So I don't have this clamped yet, so I have just a tiny amount of flex going on, but I'm close enough to a 0 that I can run the job from this setting because I touch off before every cut and reset 0 using G92s. I reset Z0 for using G92, the temporary register for the offset. So all I need to do now is raise 5 millimeter, and I'm going to track it down the line. I know it's 24 inches, so I'm just going to program in. I'm going to program in 20. That's far enough. And run this thing down to the other end. And I can put my mirror here and kind of watch it track too. That always helps. Didn't have it ready. Okay, now I think when I picked it up, I moved it because I saw something move. But you can see that I'm off a little bit. I'm going to send it back and make sure I'm still on at the other end. Track. Because it's definitely, I've had to adjust every piece by about a millimeter. Yeah, something. Looking down the line there. I am about a millimeter north. When we come down a millimeter. Well, I got my 20 millimeter distance program. Not 25. Okay, I'll change that one. Alright, so I'm going to come my way a millimeter. And that looks pretty dead on right there. Okay, and now I'm going to send him down 20 inches again, or 500 millimeters. And now my mirror's in place so I can watch it track. A lot easier to see. Yeah, it's tracking towards me. Well, this is tracking exactly across. It appears that. What I have to do is I have to hold this end and just pull by about 2 millimeters. That's good right there. Now, while that's in that place, let me send it back. Lightly put this down so it doesn't move. And I can see he's on pretty good. So I'm now going to clamp it, and I'm going to go to the blue chip crab leg clamp, which can reach in from back here at the table and stay out of the way of my cut. So I think I previewed this on the last video. I don't know if you can see it from back here. I have a spring, piece of spring steel here that it's arched, and it serves as a spring. And I can adjust the tension by moving it in and out. I can adjust my reach by moving this extension in and out and moving my foot up and down the tube. So I know if that arch is about halfway. That's pretty good tension for this situation, and I can kind of gauge it by how much my foot back here is elevated prior to clamping. Has about a 1/16 of an inch of elevation on it. When I clamp it now to my frame, that's going to give it nice tension. And I can see it apply the tension. Now the other thing that I do is I use this for my electrical connections. Well, I guess there's two technically. So there's the work lead from the plasma cutter. Put that on now. Make sure he's got good contact. And then I have an earth ground that I put on as well. So I always cut with 2 clamps on my material. One's the work lead back to the plasma cutter, and the other one is an earth ground. The frame is also earth grounded. And by that I mean I have a rod outside the shop with a clamp and a cable that run in here, and I use it to ground these components to mitigate RFI and EMI. All right, now just make sure nothing moved. size as good as it used to be. So we're pretty close right there at the dead center. And if I bring it back and watch it track, it's tracking right down on dead center. So we're good. So I'm going to call that a winner. All right. So now I can bring the torch rapidly back to 0 with another macro. Okay, so I haven't set my 0 on my x-axis yet. So I'm going to raise it. I'm going to move it out so I can see it a little easier, better angle. And now I'm going to just walk it over to the edge. Right there. All that 0. You know, I'm not sure I zeroed the axis when I was on the line. Huh. Okay, well, we're going to go to 0 and find out. Take the torch down. Yeah, it's good. Okay. So, move it up the x-axis, edge here, and it looks good, tracking good. It should, but that's a square edge. All right, so I'm 0 on my corner. All right, and I'm clamped, and now I'm just going to check to make sure I got no flex. I got very little flex. Well, I got some flex down here. Got quite a bit down there, actually. Yeah, that's fine. That's a little more than I want. Let's see. How close do I get to that? Yeah. The other piece. Oh, I'm quite a ways from it. I can throw another clamp right there. Got 2 crab legs. Just for this reason. So we'll get the second one. Get another welding clamp. Set this in here. So I can, right there, I'll get away with it. Just right. So here I'm a little closer, so I got to take a little more tension out. And then same thing. Get my foot on the rail there. Clamp that down. Solid. All right. Okay. Now, next thing I do, I've already got my my G code produced, generated. I use SheetCAM. I'm going to hopefully you can see the screen to a certain extent. Come to really like SheetCAM. One of the best things I like is the ability to turn on and off the tool path with the click of a button, and it shows me the width of the kerf if I have it set right in my tool. And you know, I haven't measured that today. Measured it the other day with this tip, and it was 1.6 millimeters, but I was cutting 1/4 inch. Let me measure a plate that was previously cut today. And I was just checking to see if my edges are square, and they are. That's always good. That's a good indication that your swirl ring is going the right way, but there's another way to know that. We can talk about that later. So I'm just going to throw some calipers on here. And I know this is supposed to be 2.75 inches. Oops, I'm sorry, wait a minute. Only one of them is 275. The other ones are 3. Because I'm coming in at 320 on this piece. It's a little more than I thought I'd have. So let's see, 320. I'm cutting from the outside. So the tip is wearing. That's what that means. So I'm cutting from the outside, and it's 1.6, but the orifice is 1.1, but that's, I mean, that matters to a certain extent, but you don't really base it off of there. When that tip was new, 1.6 was a good number. Now it's got a couple of meters of use on it, and it seems to be settling in around 20 thousandths over on an outside cut. So that means, and I got it programmed at 1.6. Huh. That's interesting. That means it's actually cutting at about 1.4 or even 1.3. Wow. Right? It's coming in from the outside, and it's 1.6, and it's not going far enough. So I need to narrow my curve. I'll be dang. Check the narrow one, just to be on the safe. This one was supposed to be 2.75, and it's 30 thousandths over. So I'm 20 to 30 thousandths over. Well, you know what? I moved the daggum kerf setting the wrong way then this morning. From a cut I did yesterday, I thought I was too narrow, and I made it 1 point. It was 1.5, and I made it 1.6. I thought I'd be dead on. I went the wrong way. So I'm going to rebuild my code with a kerf setting of, so I was 20 over, so half of that is 10. A tenth of a millimeter is 4 thousandths. So I could almost go 3 thousandths, I'll go 2 thousandths. So I'll make it 1.4. At least I should be within 10 thousandths. Not that it matters, I just like, you know, someday it will matter, and I want to know how to get there. So that's why I'm going to do that. So I'm going to change my 12 gauge 60 amp tip parameters to a 1.4 millimeter kerf. And that will narrow that overall dimension, changing it from 1.6 to 1.4. So it should narrow it 2 tenths on each side, 4 tenths overall, 16 thousandths, and I'm 20 to 30 off. I could actually go to 1.3. God, I've never used the tip at 1.3. Holy cow. All right, I'm going to do 1.3. I'm going to go for 0. Zero margin there. My pierce height is 3.2, and my cut height is 1.5. And that's that. So now I need to change the operation file at all. I just need to change the tip and rejam the code. So what I like to do is show the code and generate with that window open. So everything is already filled in. I'm just clicking yes, okay, all that. So here's my new code. I should actually put a comment in here that tells me what my kerf is. Because you really don't know, because it's buried in the XY coordinates. Well, I'm not going to do it now. But now if I come over here and toggle to the source file, it reloads automatically. parentheses and it's changed. Which, let's see, let me just check an XY to make sure it picked it up. So 29.8, 26.8 on the first statement. 29.8, 26.8, okay. Alright, so we regen the code. But anyway, I use LightBurn to design my part. Then I mark it and I export it under File, Export, and I save it as an SVG. And then I read that SVG right into SheetCAM and build my operations based off my tool and the layer, and gen the code. So it's pretty smooth. Okay, so we got that. Got my 0. All right, next thing, I'd like to look at the top down view here. Double check, nice and flat. I serviced the torch, I tested the torch. I'm going to move, well, I don't have to do that. Yes, I do need to. I'm going to bring it up, bring the torch 10 millimeters off the surface, and I'm going to run the outline. Since I threw another clamp in, it looks like it's easily going to clear, but just to be on the safe side, I regen the code and all that. What I can do with UGS is tell it to run the outline of everything that's involved in the cut. So it's not running every cut, it's just looking at the perimeter, and it's running that outline. So let me do that. And then I'm going to watch to make sure that I am always inside the edge of the material, which I am. It's tracking nice. And it won't collide with this clamp, which it doesn't. All right, and that's good there. So we're good. Okay, pass that test. All right, now the next thing I do is I'm going to go back to 0. And now that I have everything clamped, I'm going to touch off one more time. See if putting that clamp down there changed anything down here. I don't think it would have. It did. It changed it by 0.3 of a millimeter. So if I do it again, I should be 0. And I see a little bit of flex there on that corner is what happened. Okay, but that's fine because I don't get too close to that corner when I'm cutting in terms of piercing, so it'll be fine. All right, now I got my switch down, so it's not going to fire the torch. I'm going to do a dry run on a couple of moves just to make sure things look good. So the first thing it's going to do is it's going to pierce those pilot holes, those 2 pilot holes in each part. So it does that because that's the only interior cut on the whole sequence of parts. So I'm pretty happy with that. I'm just going to cancel this. Reset it. Bring it back to 0. And we're ready to cut. So I got my wires on, I got my clamps on. This is my Fumes Extractor. You know, plasma cutting is a little toxic, depending on what metal you're cutting. Mild steel is probably the least toxic, but regardless, not good to be breathing that stuff in. So I got a 2200 CFM fan that sucks through this tube and throws it outside. And I get fresh air in at the top of the door. and it's magnetically attached to the back. Okay. The other thing I do is I put a shield up because I'll be sitting here. So I put a shield up with a little welding clamp here. I have this is to keep water from blasting all over the place if the torch were to stop over open water for any reason. And I just slide this in to keep the water from blasting. And I always put some needle nose pliers out to be able to pick out a piece of a part, you know, that may have tipped after it's cut, and then it'll interfere with the torch movement if it doesn't clear it. I have a 30 millimeter clear when I move from cut to cut. And I don't have anything on here that's going to tip and do that, I don't think. I think the slats catch everything, but I don't know. One of those plates could possibly tip. But I think we're good to go. So, I'm going to get this started. Kind of set that up there and get out of the way. Alright, so I just got a little mental checklist I'm going through here. Torch is good. My voltage, my THC voltage, since I've been cutting, I know it's set right. I'm on 81. Might go to 82. We'll see how it's tracking. But my Z error has been minimal since I got my circuit. I have it's still on a breadboard, but in my blog on the MillRight forum, I write about this circuit. This is the 555 circuit that, I'll just leave that off, because you'll probably see that blue light. The blue LED that's on there is going to flicker. When it's off, the Z motor is disabled. And you're probably going to see it go off. You may not see it go off at all, because here's the part we're cutting out. So it's not a sharp angle, I got a radius. And it's a radius that it might slow down enough to turn it off. That'll be interesting, I haven't noticed. And it'll be off when it cuts these holes. You'll see it go off for these holes, because it actually does a little wiggle. A little circular wiggle. It's supposed to be, I think it's an 1/8 inch. No, it's a 0.1 hole. So it's about 1/8 of an inch. And it's pretty close to that. So there's a little wiggle it does there. No lead in. The lead ins on this part are up in this corner here, and it's a 6 millimeter arc lead in. Okay, we're ready. I'm going to click start, and then I turn this away so the shield protects it. I got to put my arming switch up. Sometimes forget that. Put my glasses down. Sometimes forget that. Turn on the extractor. And go. Cut to get a voltage reading. I mean, it's given voltage, but it's not stable. I'm going to demonstrate the interrupt. So there you go. Pushing that button throws the door alarm. And I can stop like this, just to check to make sure I got no debris at the bottom of the tip, no dross. If you do have dross at the bottom of the tip that it might have picked up on a fish, you'll see that the next pierce will have a higher voltage when it starts to cut, because of the dross, it's not at the proper cut height. So it cuts it off every time. The center. When I see the voltage spike a couple of volts from the normal, I know I got some debris there. Which is not the case this time. I just wanted to demonstrate. That thing's clean as a whistle down there. And I can see I got a recent tail of dross all going in the same direction, which is from the movement of the torch after the pierce. And I haven't looked at my LED up there to see if it's going out, but I'm going to watch it on this one. So I'm going to resume by pressing the black button. Oh yeah, it's going out. Good to go. Alright, so now we're going to cut one out. So I'm going to do something this time. When it's cutting the next one, I'm going to interrupt the cut like there was a problem. Like it hit some dross and I needed to shut the torch down. So I'll throw the toggle like I'm going to be shutting the torch down. And then I'll have to come back and finish this cut and I'll show you how I do that. So just set this off, I'm going to check for debris, got no debris. Torch is still solid, everything's good, so that's good. If I was cutting, making a 10-minute cut, I would do this periodically. It also gives my air compressor a little time to catch up. Not that it needs it, but it doesn't hurt. So I'm going to let it get started, and then I'm going to shut it off. Hopefully you'll see it. Now the torch is off, so the THC sees no arc, it's not trying to move. Okay, so now I'm going to rearm it so it cuts the last one. Alright, that's it. That's the job. Now, if I had a part that fell through there, I could just put this under there like that. Save a bunch of water supply. So, same kind of side. I'm going to throw my switch off. Let the air stop. So, what I did here was I simulated there being some kind of a cut problem. You know, dross maybe, knocked my torch, you know, whatever. And of course, turn the torch off with this toggle switch. Now, in order to resume that cut, I got a couple of choices. In this case, I got a pretty short job that's running here. So one choice I have is I can just rerun my job with the torch off, disabled, and let it run through all the steps. And when it gets, so I know what my speed is. My speed's 18 millimeters per minute. So I know, I think 2,000 millimeters per minute is 30 millimeters per second, if I'm not mistaken. Figured it out once. It's in that ballpark. So 1,800 is pretty close to 2,000, within 10%. So if I could measure, and I will, take my ruler out with my millimeter scale, and I will measure out 30 millimeters from the last point of the last cut. And I'm going to put a mark, 30 millimeters before the end of the cut, where it stopped. I'm going to put a mark. And when the center of my torch is at that mark, I'm going to enable my switch. I'm going to throw my switch. That'll fire the torch, because M4 is already on. So that's going to take about 1 second, which is my delay for the torch to fire. And I can, that's the delay, basically. The delay before movement. Well, the torch is already moving, so I need a delay. I'm actually going to fire it a tad, probably about 5 millimeters before that, because I want to make sure. I've done it a little too close, and I've had to fatigue the metal there to break it loose after the cut. But I'm going to make sure it's on by the time I get to that slot, by the time I get to where it needs to cut. So that's one way to do it. Just rerun the job. If it's short enough, wait till you get to that point, throw the switch, boom. Another way to do it is in UGS, I can tell it to start from a line. But then I'd have to find that line, in the program code, which that would take probably as much time as just rerunning the job. Or I could go to SheetCAM and I could take this cutout, this shape, and only this shape, and I could create it, put it in a new layer that I create in SheetCAM. I usually call that layer fix. And that fix layer now has that shape or shapes that I missed during the primary cut, and I just recut them. But I would do the same thing in that I would have the torch disarm during what it thinks is the pierce move, and all this up to here, and I would arm it right when it gets to that line. So either way, I'm going to enable it in that way, because the part of the cut is already done. If none of the cut had been made, then I would arm the switch and just let it start at the beginning. But here I don't have to change anything, change files or anything like that. I'm just going to rerun the job, and I'll show you how easy that is. So hopefully this angle, yeah, you can see that. Okay, so again, just to make sure it's clear. So I'm gonna run the job with the switch off. Just do a reset. Okay, run the job. So it's going to move, no cutting. I may fast forward through this when I edit the video, but you get the idea. I'll let it do a few here, and then I'll probably edit out, the 2 minutes that it's going to take to get to that point. But know that when it's coming over to cut this shape, which is the third shape, so it'll cut this one, then go to that one. When the torch gets here, where I've measured 30 millimeters or thereabouts, I'm going to enable it with the switch. Whoa, there. Oh, so that's a problem. Okay, so it tipped. I've never had that before. I'm going to enable it with the switch. Whoa, there. Oh, so that's a problem. Okay, so it tipped. I've never had that before. All right, I should have been paying attention. Okay, so what I got to do now, it basically threw the probe alarm. So basically it was on a probe command to touch off, and it never found the material because it tipped. And let's see, what do I have to do? I think I have to unlock, reset, unlock, and bring it up manually. Yeah, bring it up with a manual command. Okay. However, I basically have to restart the job since I hit reset. So now, fix that. I'm going to use this, which is what I should have been doing, paying attention, and it's going to keep that from happening. And I'll have to move it when I get over here. So, there you go. Live and learn. Okay, so I'm just going to restart it. This one's not tipping because it's not cut out. All right, so it's going to trace this one, then when it comes over here, it'll touch off and I'll fire it when it gets there. Get this ready. Okay. Okay, now we've already cut the other one, so I can interrupt the job right here. So the last one was cut. So that's how you recover one way. I mentioned 3 ways to do it. 2 of them require dinking with the code. Well, to the extent you gotta find the line and start in UGL. I could probably make that process easier if in my post processor I throw a comment in that I'm starting a new shape. The code indicates that too, because obviously I can search for probe commands. But oh, that's the other thing I wanted to check is what's my Z error after all that. So the way to do that is I take it up, I do a touch off. There's another way to do it, but this right now is I didn't record the position originally. So, oh, I got 0 Z error. 0. The circuit did a great job. So, all right. I really don't think it came into play a whole lot because of the less than 90-degree sharp angle I was doing. But anyway. Let me tear this down, and that's the end of it, really. So what I would do here is just retract, bring it to basically the home position, machine home. I rehome it because it does have some Z error, but I mean I don't even think it's a millimeter. And then I'm going to just take my parts down, disassemble clamping, it off of here. Slow this over here. And take the scrap out. That's right out. Looking at the back of it, that is a great cut. Dialed in. I got no dross other than at the pierce hole. A few times, well, that's probably when I restarted it. Yep, that was a restart. So, and over here, that's the scrap. I don't care about the scrap. Parts have a similar, I mean, there's barely any cleanup, and my edges are square. Now, well, I'm not going to do the one that I restarted the torch on. Let me do the one next to it. And I'm going to dry it off and measure it with the dial calipers and see if our corrected kerf brought our dimension within 10,000ths of the drawing. It's looking good. It's looking good. Okay, this guy is measuring within 2,000ths. It's 2.98, not 2.980. Call that 3. That's 3 all day. That's pretty good. Wow, that's a 1.4 millimeter kerf on a 60 amp machine tip. I don't think I've ever run that. Well, I don't think I've ever had the machine as dialed in as it is, and it's that way at the other end too. I'm less than 2,000ths under my drawing dimension. So, and obviously it's repeatable. Let's check the third one. Two thousandths. That's 0. That's 3 on the thousand. Okay, so that one's plus or minus 2. This is supposed to be 275. Let's see what it came out to. And it is, that's interesting. Who'd have thought? So this one is measuring a little under. Now, I've got a little angle on that edge. And that one's square. Well, you know what? This one was right up to, I had the thinnest of my waist was on this part. That's why I had to reduce it to 275 to fit in that waist area. And it's about 6,000ths under. So there could have been some thermal movement going on during the cut on that one edge, because the edge that was up there on that side is not as square as the other side. So definitely something going on there. So that's good to know. When you're cutting something that close to an edge, you may give up a little accuracy, but there's no other reason for it to be off on that dimension and, be right on 3 inches on the other one. Let me check. So I can feel where the torch restarted there. So I'm going to check after the torch restarted. That is 3000. That is right on. And this one is, now this one is 3,000ths over. Well, no, it's not. I had the calipers a little sideways there. So it's actually under by 3. Over here, okay, on second measure, hold on. I'm getting a little under, a little over. I'm getting over by 3. Anyway, hey, we're that's chicken shit. I mean, this is a plasma cutter, so I'm happy if I'm within 15 thousandths. It's nice to know though that I can get it dialed in like that if necessary. Okay. What else? That's it. I mean, there's just, you know, standard cleanup at this point, but that's all there is to it. So take care. Thank you.